There's a theory that as soon as an athlete is on the cover of Sports Illustrated, they suck in their next professional athletic event.
Yeah.
They fail. Have you ever heard this theory?
Oh, yeah.
There's a theory that as soon as you're on the cover, it's like a curse. As soon as you're on the cover of Sports Illustrated, your next game, you're going to suck. No.
It's pressure.
It can be explained statistically, as far as I know. It could be attitude. I shouldn't say no. It could very well be attitude. It could very well be attitude. It could very well. But I like the argument, and this is an argument, not a proof of anything. It's called regression to the mean. When you're on the cover of Sports Illustrated, what have you been doing? Probably kicking ass. Probably kicking ass. Probably operating above average. I'm guessing, operating above average. Unless your average is changing and you're actually getting better exponentially more quickly than you should be, what's going to happen when you're above average for a period of time? You're going to regress back to your average. And if you're above average, to regress back to your average, you have to start sucking to regress back. It's like flipping heads a bunch of times. Eventually, you're going to have to get tails to cancel those heads. The question is when it happens. Now, of course, you can counter that by saying you only notice it when the athletes suck after they've been on the cover. How many athletes are on the cover that don't suck the next week or the next 2 weeks after? I don't know. I don't know the data on that. But I do know that very often things happen, and that's why I say how much of it is random chance, Gene, or actually something going on with the coins. I don't know. Let's see. We're going to put it all together. Okay, you got it to work? Ish. Okay. So.
I'm not going to become a professional coin spinner.
Well, thank God for that. No market for it. Okay, we are recording now. Are we recording? Yeah. Solid, solid. Okay. Now let's collect some data. I got 300 of you, or I got 300 spins altogether. There's a reason I had you each do it 10 times. There's a reason I had you each do it 10 times. Because I wanted you, A, not to have to spin them hundreds of times yourself, but also I wanted you to kind of have an interesting result for yourselves. Like, for example, 1 head and 9 tails, or 5 and 5 exactly, or something like that. Anybody get none of anything? Like 0 heads and all tails, or 0 tails and all heads? That never happened. That hasn't happened yet. It can happen, of course. It just hasn't happened yet. So right now, we've got a nice sample of 300, yes? Yeah. Let's break that down by heads and tails. Easy. Heads and tails. So let's use the TIs to collect this data, just because it makes life easier for all of us. Plus it gets us back into them and lets us remember how to use them while we're at it. Say that again? Goodness gracious. Chords. Well, this is what we're going to do. What we're going to do is we're set a little distribution. Just like we did back in the day. Can we see that okay on the screen? Is that sort of visible in that little viewfinder? Is there a little yellow rectangle on it?
Yeah.
Okay, good. Hopefully, I mean, it'll be much larger on YouTube screen, obviously. As long as it's in the shot.
Yeah, and you can see the bleeding box. So
let's zoom in a little bit then. This might be worth getting closer on. Oh yeah, let's get a little closer on it. Excellent. All right. So first thing, let's go to our stat editor and set up the beginning of the distribution. This will just be a frequency distribution, not a probability one. Because in order for it to be a probability distribution, this is binomial, yes? Because you're either going to get heads or tails on each flip. So you might be tempted to go to the disk fill program and run a binomial. But what's the problem with trying to do that right now? We don't know what the probability is, therefore we can't generate the distribution. Remember, the next thing it asks you in the distribution is, what's the probability? You don't know what the problem, that's the whole point of the experiment, is to figure out what the probability is. It might be 0.5. It might be exactly the same as flipping a coin. In which case we get, if we were doing this as a test, and we decided that it was 0.5, what kind of test would that be? Remember our words from before? It would come back as a, what kind of test result? Positive, negative. I'm trying to plant this seed in your mind now. If we went into the test saying, I don't think it's any different than flipping a coin, and then we decided that it was no different, it would be a negative test result. It would be true negative if we were correct, but it would definitely be a negative test result, right? Because nothing changed. If we decided something different, we would call that a positive test result. It's something different. But that's what we're trying to discover today. Is it something different? It might not be anything. It might be exactly the same. Let's collect some data and see if we can figure it out. So, stat edit. Stat edit. I got some crap in there. We can clear it out. It's probably important. I don't know. What are the random variable values for L1.
1 and 2. Or 0.
0 through 10, correct? For each of you guys, yeah? Because on each of your I like the 1 and 2 because heads and tails, but because you guys spun 10 times each, let's keep track, let's call X number of heads. Let's keep, because I'm asking, I kind of want to figure out what's the chance of heads. So we're going to let X, we'll put X up here, equals the number of heads out of 10. Now Christina, I love what you said, 1 and 2, yes or no, it was heads or it was tails. But the trick is we have to look at all the combinations of how many times. Because for example, if you got 5 heads and 5 tails, there's a whole buttload of ways, I think it's like 120 ways of doing that. Because the 5 heads could be in, whatever, 10 times 9, a bunch of ways. The heads can fall in a bunch of different places in the line of 10. So, let's go 0 through 10. Alright, and now comes the data collection. Nobody got 0 heads, correct? Anybody get 1 head and 9 tails? We got 1, 2 of those. Okay. 2 heads. We got 1, 2. Matt, was that you or did you get 2 tails? You got 2 tails.
Yeah, I got 2 heads.
You got 2 heads, only because we talked about this. So that's 3 of you guys. You got 1, 2, 3. Okay, 3 there. 3 heads, the rest tails. So that's 1, 2, 3. Okay. 4 heads, the rest tails. 4 heads, the rest tails. 1, 2, 3, 4. Half and half, which is what we're expecting, right? We're expecting half and half. 1, 2, 3, 4, 5, 6, 7, 8, 9. Beautiful. 6 heads. 2, 3, 4, 5, 6. Thank you, Laura. Sorry about that. 7 heads. 7 heads. 1, 2, 3, 4, 4. Good. 8. 8 heads. Nobody got 8? Anybody get 9? Nobody got all 10, correct? Okay, beautiful. Ooh, goodness. No plus sign. I want to check one thing real quick to make sure I added correctly. I want to sum up. I'll go back to that screen so we all have the data. I just want to check one thing before you guys. I want to sum L2 and make sure it sums to 30. 31.
I went twice.
You did?
I did.
Are you serious?
Yeah, I did.
So,
I rolled the thing 20 times.
oh! Can we take... No, what the hell? 310, that's perfect. I love it, Michael. Thank you. So make sure I update my data. Thank you. That means I added correctly? Holy freaking crap. That never happens. And it wouldn't matter, except with a sample-ish this small, it actually does matter. We can actually weigh it. So thank you for telling me that, Mike. I appreciate it. What did you get both times?
I got 3 heads on once and then 5 and 5, but they were in both the rows. 5 heads and then 5.
Oh, that's interesting. 5 and then 5, right? So, what's wrong with my deck of cards now?
It would be a lot more likely for that to happen in coins
Christina,
than
don't
in
ruin my
cards.
moment. Don't ruin my moment, Christina. I'm sure there's 30 of you and only one happened to one person. Never mind, you get the point. All right, so here we are. So, what should we do now? Well, first let's add up how many heads we got, maybe, all together. You can run a 1-bar stats on this, and it is a cool little trick that'll tell you how many heads you got. So do your 1-bar stats like you did back in the day. Remember to do L1, L2, because that looks at the data and the frequencies, yes? Can you see how many heads we got? It's hidden in there. It's 142. It's kind of hidden up there. It says n equals 31. I'm calling it 310 because it's counting 31 of you, but each of you flipped 10 times. But this guy right here is actually L1 times L2, and blah blah times L2, L1 times L2, and the sum of all of that. So when it says sum of X, it means sum of X times F. You guys flipped 142 heads total.
Slightly skewed to tails.
It is, isn't it? It's slightly skewed to tails. It's slightly skewed to under for heads. But let's put that up here. I'm going to call that X, if that's okay with you guys. 142 heads out of 310 trials. There's Gesundheit. There's our data. There's our data. So Kate has a theory, I like it very much, that it's slightly skewed to tails. Slightly skewed to tails. And that's because she's doing in her head 310 divided by 2 is what, 155. So if it were perfect, it'd be 155, 155. But we don't expect perfection, even if it's mishmash. There should be a slight bit of error in the sample. That's what James was talking about before, with the heads and the tails. But this, You were talking about something called non-sampling error, which means something we can control by a goofy little, kind of like a pitcher putting spin on the ball, right? That's not random, that's planned. We would expect some kind of deviation from 155 to 155. You wouldn't expect it exactly to be 50-50 over 310 trials. The question I have is 142 what? What's the question I'm thinking of? Because you said, Kate, you started this question. Blaming you for what was in my mind, this idea in my mind. She said 142 is slightly skewed to tails. My question is it so skewed to tails that I think that this is different than that? That's my question.
I'd say no.
I don't know right at this point. I don't know. Stacy says no. 142 is close enough. Let's figure it out. Let's take a look and see if we can figure out if it's close enough. Let's look at it every tool we have right now. What should we do first? I'll take the data real quick here, friends, in the spreadsheet. We have 142, right? Not 1,042. Beautiful. Okay. What can we do to test it? To test this kind of theory? I'm going to pull this back a smidge. What's one thing we can do with our data? What do you think? Draw a curve and see if it's a bell curve. How about that? I love that idea. Well, let's take a look. Can I'm going to take this off because that's kind of in the way. Let's graph this. Yeah? Let's make a histogram, shall we? I think it's a great idea. Let's make a histogram. So, in case we need a refresher, second y equals, stat plotter, grab one, turn it on. Histogram's right over here. Good so far? And then grab L1 and L2, make sure it's looking at both. L2. We may have to do some finagling of the axes, which we will do momentarily. We'll just deal with this right now. Good so far? Zoom 9. That's the easiest way, right? Zoom 9. There she is. May I finagle? I think we should finagle the horizontal axis. It makes it easier to look at. It decides what it should be, and I don't particularly care for it. Window? Yeah, I'm going to make X max, excuse me, puberty. I'm going to make X max. Do you remember the trick we always do? Our biggest X value was 10. But I always made it 11. Remember that? I always made it one bigger. Do you remember why?
So that way it's not on the edge of the screen.
Right. The problem was the bar has to have a width of 1. So if you make the top 10, that last bar, now there isn't a bar on the last one here, but that last bar will be cut off. So making it 11, the last bar will go from 10 to 11 width-wise. So X scale, let's make it 1. That way we actually get more of a dot plot than a histogram. We actually see every data point scaled properly. Let's see how that looks. Look at that. That's good. That's good. Christine, what do you think? What do you think? You got an idea coming over there. Let's hear it.
Oh, I was just noting that it was like skewed to the left.
First thing I noticed, and I noticed this as you guys were telling me your data results, I noticed we had a tail over here, and we didn't have a tail over here. Did anyone else catch that? We started, I think there was, who got 1 head and 9 tails? Were there 1 or 2 of you? Serena, you got 1, and Jamie? There was a 1 and 2, there was a 1 and 9 and a 2 and 8, but there was no 8 and 2 or 9 and 1. Now, granted, it's only 300 trials, so I wasn't like, oh my god, the Earth is not going to stop rotating. No, it's nothing like that. But it was interesting to me, like, wow, there's like no symmetry at all with that, with those outliers. So if there's no symmetry with the outliers, my first thought is maybe they aren't outliers. Maybe they belong in the data set. Which would go with Kate's assumption that maybe it actually is more favoring tails than heads. That's a possible. That's a possible. So the question is, does this appear to be too different from the flipping of the coins? Now here's where we can get fancy. We can get fancy with this. Let's turn on a second plot, but work this with me. Do this with me. Go back to your stat editor. We're going to do a little Excel-ish stuff with our TIs momentarily here. Go to L3, on top of L3, and copy L2 over to it. So just, and by do that, just type L2 in top of L3. So you're on top of L3, just type L2 and press enter, and it'll copy all those values over for you. What we're going to do is, we're going to run the dist fill program I just gave a bunch of you guys, and we're going to... Exactly. We're going to run dist fill, and then we're going to do super fancy. We're going to do a couple intermediate steps. Okay? So everybody now, kick out of here, Get back to your home screen.
Can you refresh here on how to get out easily?
Oh, second mode. When in doubt, second mode kicks you to your home screen. Yeah, for sure.
We barely use it.
I know, I'm sorry. These things are wonderful. I mean, granted, it's not Pac-Man technology as far as screen display, but the math they do is top-notch. So, absolutely. I just gave a bunch of you programs, some of you had them last term. Let's set up disk fill. Okay, so press the program button, PRGM. PRGM. One of the ones in there is called disk fill. Might have to go down a little further to get to it. You lost it? We'll get it to you after the class. Actually, not a problem, not a problem.
I know, I thought I had it.
Now we have to set up disk fill, which is 0 through 10. So 0 through 10. This is exactly the same thing we just did manually, but the program needs to have it reset again. I didn't write the program to be able to insert your own L1 into it. All right, we're going to do L2 of the binomial. Probability is 0.5. L2 is going to be the flip probabilities. Yes, the flip results. The flip results. So 0.5. Let it fill it. Okay, it's done. Now what I want you to do is to go back into your stat editor and look. Stat edit. Okay. Here are the probabilities that correspond to a perfect coin flip. Here are the results that we got in our experiment. All we've got to do now is 2 quick last steps. We can't compare L2 to L3 right now because it's apples to oranges. Can you see why it's apples to oranges right now? We can't compare them directly. What is in L3? What kind of data? Raw count data, exactly. Raw data. What's in L2?
Probabilities and decimals.
Probabilities. We have to turn one into the other. I recommend, since we know we spun 310 coins, if we multiply each of these by 310, we're going to figure out how many we should have gotten on average.
Can we do L2 times 10?
Yes. Put it in L4. Ready? Go over to L4. What you're doing right now is you're using your TI like Excel. You're using like a spreadsheet, which is exactly what is so wonderful about them. We're carrying our little spreadsheets in our pocket, which is great. Okay? And please, if you're sitting there going, how the hell would you ever expect to do this by hand? I would. We're going to do it in Excel in your exams and stuff. I mean, this is just because we have this in class. All right? Okay. L4 equals, you don't have to press equals, it's already set up there. Just do 310 times L2. And what that will do is essentially this for every single element. There they are. On average, out of 310 trials, we should have seen 0.3 results that had no heads at all. Now, of course, 0.3 can't exist because it's an average. You can't get 0.3, it's either 0 or 1. We should see about 3 where we had 1 head and 9 tails. We should have seen about 13 or 14 where we saw 2 heads and 8 tails and so forth and so on. Christina, what's on your mind? You're thinking about something.
Just keep going.
Notice where the largest number is? Where's the largest number? Right? Our largest number is up here at 70. Oh, I see what the problem is. I see what the problem is.
76 compared to
I see what the problem is. Sorry, one edit. Not 310, 31. Sorry, 31 times L2. Sorry guys. 30, thank you for looking like that, Christina. You brought me to my error. I have to take the 10 back out because there aren't 310 of you, there are 31 of you. Apologies. There we go. Hopefully that makes a little bit more sense.
What are the numbers after 6 and L3?
I don't know.
Raw data.
Let's find out. 96400.
Perfect, thank you.
There we go. So we were off by a factor of 10. My apologies, and thank you for looking confused because I forgot to take the 10 out. Now, what I think we can do now, the whole point of doing this, we can compare them right now. If you want, we can look at L3 and L4. We can also graph both of them and see if the graphs look starkly different. I thought we'd do that. Why not, right? So we do have to adjust our first graph, because now we screwed up L2. So let's turn on 2 graphs. Second, y equals. Plot 1's going to be great, except no longer should plot 1 be L1, L2. I think it should be L1, L3, because I think we moved that data over to L3, didn't we? Yeah. So let's leave plot 1 as L1, L3. And if you want, you just press graph, it'll still be there. There it is. But I also want to turn a plot on so I can see that new one that we just made. But here's where the TI sucks. I don't want to turn on a histogram on. Here's why. Let me show you what it would look like if we put a histogram on. And then you'll see why we're not going to do it. Turn it on, histogram, L1, L4, yeah? See, there's the problem. They sit right on top of each other and you can't differentiate them. In Excel you can, because you can get different colors, you can tilt them, there's all kinds, we'll do that kind of stuff in this class. So here's my recommendation. Turn on L2, go so tight. Make it L1 and L4. Yeah, for sure. But make it that plot right there. Why did they just change that? That's weird. Make it this second choice, and what this second choice is a line graph. It's basically a histogram that connects high points of the bars and then erases the bars. So you get a little dot at the center of each bar. We didn't do them much in 243 because there was no need to do them in 243. They didn't pop up that much. So we didn't do a whole lot of comparison of histograms because honestly that's what we do here more than we do back there. Fair enough. As far as a mark goes, your choice, you can either put a little square at the top. If you do that, it's going to look like this. You can also take the squares off if you want to, and just make the smooth bell curve. That works too. Like that. Okay? Fair enough?
Yep.
Okay. So, what do we think? What do we think? Is it deviant from what it was supposed to be? Is it deviant? I'm asking you a question you don't know the answer to. I'm asking you what you think right now. So if it feels uncomfortable, good. It should be uncomfortable. It should feel a little bit weird. Like, I don't know. Does it look the same? Does it look different? Does it look the same-ish? Does it look different-ish? It's very close. I like that. It's very close. So based on just that, who says it's close-ish? Yeah, that's about half of you. Who's the other half of you saying it's not closest or you're not sure? Those that didn't vote, I'm picking on you now. What do you guys say that didn't say it's close-ish? What close-ish? Close-ish. What do you say if it's not close-ish? Is it far-ish or is it indeterminate-ish? What do you think?
What do you want me to say?
I want you to say what you're thinking. What do you want me to say? Have you learned nothing from Terry's with me? I want you to tell me what you're thinking. What do you think, man? What do you think? It's close-ish. Okay, it's close. Let's see hands again. Close-ish. There's arguably the same. That's more than that time. Okay. Some of you are saying no, it's not that close. Good. Close-ish, but not the same. So this is good. This happens in the news all the time. All the time in the news. You hear the claim that Obama's approval rating has dropped 2 more percentage points. But then upon closer examination of the data, you realize that you can't actually say it's statistically significantly dropped 2 percentage points because the 2 percentage points may have just been a random fluctuation in the sampling.
But when he gets to 0, it won't matter.
Well, yes, if and when he gets to 0 it won't matter, or if and when he gets to 100% it won't matter. Neither of this has happened in the history of American presidents. But the idea is, here's the deal, friends. If I had you guys do this experiment again, would this curve look the same?
Yes.
Yes.
Would this curve look the same?
Maybe.
Maybe. Who said maybe not? Nice! Maybe not. Probably not. It could look the same, couldn't it? But it most likely won't. Maybe not. If you said no, I love that answer. Because it won't look the same. Most likely it won't look the same. JC, you had a question. Go.
Yeah, so me and Megan were just talking, and you're saying that like Obama's approval rating
Of course.
went down 2%. So you have a new sample,
You do.
different margin of error.
It has to be based on the mathematics of how you calculate one. Chances are it
But are
won't.
they going to be the same? So can you compare them?
You can.
Okay.
You can mathematically compare. That's what we're getting into today as well. You can compare them mathematically if you do it properly, and that's the problem. It doesn't get done properly. It goes from 9% to 8%, and they say, oh my God, dropped a percentage point. It probably didn't drop. It's kind of like when I sent you guys an email at the end of last term. It's called Headlines from a Statistically or a Mathematically Literate World. I don't know if you got a chance to look at that at all. I just said, a buddy of mine said it to me. One of the headlines was, unemployment jumps from 6.8% to 6.9%. That's the headline. The truth? Unemployment's probably a little bit under 7%, too hard to tell if it's changing or not. That's the truth. Because the fluctuations in those curves are going to happen randomly. And it might be that one of the fluctuations falls south of where it used to be, just by chance. Not because something actually is doing worse than it did before. Maybe it just came up tails a few more times this time. What we're about to start learning how to do is how to quantify that. How to actually put a measure. That's what you're getting at, JC. I love the questions you're asking. how to actually quantify that measure. How to quantify that measure. But here's the question I have for you guys. Right now, if you had to answer this question, I'm going to start and stop the camera again, because this is probably a pretty good place to reset.